squared. And we have y equals x squared minus 2x. Okay, and it wants us to find the area between the curves. Well, the first thing to do is to graph this sucker, isn't it? Which I probably didn't do. That's 5! Yeah! We're counting, good, enjoying the fun. Good times. All right, so when you graph it, who's on top? 1/2 x squared. Truly? Yeah? It's something weird, isn't it? That's 6. It's like that, or something funky like that, right?
Yeah.
I think the 8s and 9s. And did anybody go to 10? I'll take 10. It's too late. I can't do that in good conscience. So no, it's something funky. It's like it's something like that, I think. So we have to figure out which one's on top. How did you guys figure out what your intersections are? What x is that and what x is that? Good. 2 and 0. Okay, so once you find those intersections, is anybody having trouble with the calculator finding intersections? Anybody struggling? 0 and 4? Okay. 4. Anybody struggling with finding the intersection? Good reading. Okay, so whoever's on top comes first. So we're going from 0 to 4. 1/2 x squared minus x squared plus 2x.
Wait,
With
yeah,
respect to
can
x.
you actually remind me how you found this? What was it? Second
Second trace, yeah,
Second-
which is above.
second
which is
calc?
Yeah, second calc, which is above trace. And you're gonna arrow down to intersect. And it's gonna plunk a cursor on one of the functions. You're gonna wanna get that cursor near to the point you care about. And then hit
As
enter.
near as possible.
And, well, not as near as possible, but further away from the other intersections if possible. And then your second enter is gonna be for the second cursor
Does
on
it
the
have to be
second
like
function.
right on the intersection?
No, it doesn't have to be, just near.
Okay.
Okay.
And then the second one?
Yep, and then hit enter for a third time and it'll converge. It'll take those 2 cursor drops and converge them on the intersection. Okay?
You hit
Alright.
enter twice?
3 times. Are you on guess now? What did it give you the intersection?
Intersection is 0?
Yeah.
Like y and x equals 0?
Yeah, we don't care about the y's, guys, we just care about the x's.
And then to find the other one, you just...
Do it again and move your cursors over to near the one you care about. That's it. So now what's my integral? Well, I'm gonna simplify that a little bit before I start integrating. 0 to 4, 1/2, okay, what's 1/2 x squared minus 1x squared? Negative 1/2 x squared plus 2x. So now my integral becomes negative 1/2 x cubed over 3 plus x squared from 0 to 4. If I clean this up a little bit, I get negative x cubed over 6 plus x squared from 0 to 4. Plug and chug, guys. What's the hardest part? The graph. Because it's really tight, right? It's really hard to see what's what. Did you guys try zooming in on that spot so you could get a better look at it?
Would you say like the best way to go about it is to make sure you're right is to set them equal to each other, just to find those points?
Yep, you could. Yeah, absolutely. So you can find the intersections algebraically. And if you're really unsure who's on top in that region, once you get your 2 numbers, try plugging a number in between, like a test value in, and see which one has a bigger y. So for example, if it's between 0 and 4 and I plug 1 into both of these, whichever one is on top is going to be it's going to have a higher y. So this will have 1/2 as the y. This will have negative 1 as the y. So this one's on top.
So So that would be the way to do it without trying.
Mm-hmm.
Oh wait, yeah, how do you know which one's on top?
You find a test value between the intersections, like anything between 0 and 4. And you plug it into both functions, and whichever one has a higher y, that's the one on top in that region.
Okay.
Does that make sense?
Mm-hmm.
Okay. So that's that. Get your pictures. We're still at 6. I'm hoping for at least 4 more. The next wave of trains is coming in. We'll get them soon.
Higher, like, as in positive, so.
Yeah. Well, not necessarily positive. It could be 2 negative numbers,
Right,
but
but
whichever
whichever
one's
one's
top, yeah, higher. Literally higher on the y scale. Okay. Let's do number 25. 25. Is this square root of x plus 3, x equals negative 3, and y equals 2? That's the one you guys asked for. Riley, did I see your hand up? No? Okay. I saw a wave back then. I was like, oh. Oh, that was you? Oh God, I'm sorry, Cindy. Never mind, never mind. I just want to make sure everything's good. So now I have y equals the square root of x plus 3. Guys, I'm going to go ahead and make that x plus 3 to the 1/2 because I already know I'm going to have to integrate it, right? X equals negative 3 and y equals 2. I already know what this one looks like. It looks
Sorry,
like
it's
this.
A minus B, so bottom minus top.
Top minus bottom. It's always top minus bottom. Whoever's on top comes first. That's the mnemonic. Laugh it up. Let's go home. So here's my x plus, yes. Yes, I can extra geek. I can intensely geek with the best of them. Y equals 2 looks like this. Okay, that's this one. And x equals negative 3 will be my vertical green line right here. So here's negative 3. And we're going to integrate from negative 3 to what? Anybody? 1. How did I find that? So algebraically, let me show you this one. This one's actually simpler than you guys think. So we set the y's equal to each other because y equals y. X plus 3, so square root equals 2. Square both sides. X plus 3 equals 4. X equals 1. That was very quick, right? So far, so groovy. So now what? Who's on top?
2.
Yeah, who's on the bottom? Don't overthink it, chickens.
Y equals square root of plus 3.
That's 7!
There was a little like shortcut to like plugging this into your calculator.
It would come right now. So you could plug this into your calculator from negative 3 to 1.
Yeah, but how do you get
Oh,
there?
math. Arrow down to integrate, or function int. It's function int.
Okay.
F and int.
Well,
Okay, so I'm going to separate these functions out, these integrals. And you guys are going to tell me why. And Caitlin, keep in mind, I still want to see this work. So you can check your work, but I want to see the math.
you want to see it up to the point where like you plug in the
Where you would actually plug
A
in
minus
A and
B.
B. Well, B minus A.
B minus
Yeah.
A. Yeah, that's fine.
Okay, so why did I split those up? They're different integrals. Which is the 2? That's integral number, and this is integral number 2. So when I integrate these, I'm going to use 2 different methods. I'm using integral number 1 for the 2, and I'm using integral number 2 for this stuff. So what's my u? X plus 3, what's my u prime? what do we have?
1.
What do we want? 1.
1.
So we can integrate now, right? So this becomes 2x minus x plus 3 to the 3 halves over 3 halves, and we're doing this from -3 to 1. I'm bored. You guys can finish this off. Right? Awesome. Yeah, you can. How many are we at? I need 3 more, y'all. Who's missing? A whole bunch of people. Let's see.
You said 10?
Yeah. 10 was my number, but I said it late.
Can I see if I can do this?
What?
Can I see if I...
Yeah, talk to me. Talk it out.
Okay, so x and then parentheses 1 minus, it would be 2/3 parentheses 1 plus 3 to the 3 halves. Well, but you plug in 1.
Yeah,
Plug in 1.
now you're plugging in
And
1.
then you subtract the same thing, but with -3 plugged in for x.
Yeah, so we have basically 2 minus 2/3, 4 to the 3 halves, right? Minus -6 minus 2/3, 0 to the 3 halves. That's 8! Hot damn! Okay, I'm gonna move this now, because it's getting in my way. Okay. It's making me happy. Alright, so this is easier than you guys think. So let's start with this. 4 times 4 is 16 times 4 is 64. So that's the cube taken care of. What's the square root of 64? 8. 8 times 2 is, so we have 2 minus 16/3. And then we have a minus a -6, which is plus 6. And then this all goes to 0, right?
So you have 8 minus 16 thirds.
I have 8 minus 16/3, which is 5 1/3, which is 266, is that right? Yeah, I'm gonna say it's 266. Somebody check my work.
8 over 3.
8 over 3, which is, yeah, 266. Okay. Roughly, or 2.67 if you're really being crazy, which I'm not. Because do you think I really give a damn about it, you guys? No, I want to see this process. So, Caitlin, to answer your question, I want to see it plugged into this point right here.
If you want to simplify it.
I want it plugged into this point. I want to see all the numbers plugged in the proper places with the proper signs. And then you can do your integration in your calculator.
Okay, but like you simplified it. So what if I had it in the form of like 2 parentheses 1?
That's fine too.
Okay.
Yeah. Okay, just so that you tell me somehow which numbers you plugged in where. Okay? Parentheses matter here, guys. Is this the same as this?
No.
No. What's the input in this one? Are you sure? Now what's the input here?
Oh, it is the same and now it's
They
not.
were the same and now they're different. You guys see the difference? Okay. Here this becomes 9. This is -9. Not the same. So watch your parentheses, watch your inputs. Okay? Any questions on this one? I like having it color coordinated. I really should upgrade my calculator to one with color in it, but I just feel so warm and fuzzy with my old block. It works so well. I've had this model of calculus, not this calculator, because there was a semester where I lost like 4 calculators. That was a bad year.
I lost one.
Yeah, it sucks. But no, yeah, I've had that model of calculator for like 18 years now. So, it's a good calculator. It feels familiar, like an old pair of shoes that you love, you know? So, works. So, today we finish up integration. Today's the last day of integration. Today's the day we've been working forward towards this entire semester. It's not that sexy.
What more can we possibly do?
Trust me, there's so much out there. This barely scratches the surface of calculus. It will be. God. All right, so here's the day. And to really nail it home, it's easier to give you guys the handout and let you make notes and stuff on that. So here you go. 1, 2, 3, 4. Yes. 1, 2, 3, 4. 1, 2, 3. You didn't quite lose yet. It's still.
You were 7, I was 7.
Aw, but you were so close. So close. So close. You're welcome. 1, 2.
Ew, you're bringing economics into this?
You 3? Okay, good. Yay! Toys. All right. So there are only 2 formulas we care about in this section. And they are specialized versions of the integral between 2 curves. So let's take a look at it.
What's the title?
Consumer and producer surplus. How many of you have had econ? One or the other, macro, micro? Okay, so, oh God. 3 of them?
I'm in like international trade.
Sorry, thank you.
You were my favorite teacher until now.
Aw,
I'm just kidding, I'm just kidding,
I know. I was never your favorite teacher. Okay, so let's take a look at this. There are easy mnemonics to remember this stuff. Supply goes up, sup. Supply, there's an up in the word. Demand goes down, D for down. So all you have to do is remember to draw those little curves, and the intersection point right here is equilibrium. Okay. This value here is X at equilibrium. X is production, guys. So it's units produced and sold. So X is production, and Y, like so often, is dollars. Except now we call it price at equilibrium. So this is price in dollars. Okay? Supply and demand are both price functions. It's helpful to label them both because P equals blah, 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 blah. It doesn't tell you if it's supply or demand unless you graph it, and then you can see if it's going up or if it's going down. Okay? So price at equilibrium, quantity at equilibrium. Wait, what's price times quantity again?
Revenue.
Revenue. So price at equilibrium times quantity at equilibrium equals revenue at equilibrium. This becomes important, guys. So if you have supply and demand and you need P sub E and X sub E, how do you go about finding them? You can do it one of 2 ways, your choice. Whatever floats your boat. Calculator. You graph them, right? Find the intersection, and this point is literally X comma P, isn't it? This point is X comma P. Because it's literally X and Y. So this point consists of an ordered pair, which is X sub E and price sub E, P sub E.
Wait, how would you graph that?
You just graph the two functions, supply and demand,
Okay.
okay? And find that little x.
And to find that point, you would do like the left bound thing and the right bound thing.
Yeah, literally the intersection, the second calculate, intersect, first curve, second curve, guess.
Oh, this
make.
like okay,
Drop
like
the,
we're
drop the
doing.
cars on the functions, they'll crash.
Okay.
Okay, so there's something else I need to show you guys though. This region here, tied to demand, is called consumer surplus. Because who controls demand? Is that the consumers or the producers? Consumers control demand. We have complete control over that. So that's consumer surplus. And then producer surplus is this region right here, which is tied to the supply function. Because who controls supply? Consumers or producers? Producers control supply. That's right. So you guys can see that this shaded area of producer surplus, one of the edges is the supply function. So it's literally tied to supply. Notice that it doesn't touch the demand function at all, except at equilibrium, this little point, right? And the same thing with consumer surplus. It runs along the demand curve because consumers control demand, and it only touches the supply curve at the point of equilibrium. Okay?
So, both of those shaded areas, they're always gonna be above the supply curve.
Yeah, they'll both always be above the supply curve. Yeah. So let's talk about what the hell consumer and producer surpluses are. Anybody know? All right.
Well, it's pretty self-explanatory.
Is it?
Sort of.
Talk to me.
Well, a producer surplus is when there's more being produced than demanded.
How about we're talking about money here? Okay.
So it's not based on like quantity of items. It's based on money.
It's based on money. So here we go. This is the easy version of it. How much does the new iPhone go for?
Liver.
What? A liver?
How are you?
1,100. Helena.
11.
Yes, exactly. So consumer surplus. Let's say the new iPhone is $1,100, but you're willing to spend $1,300 because, I don't know, you're sick or something. You're willing to hand over a liver, like you said, Justin. Yeah. So let's say you're willing to spend $1,300, but you walk into the store and you decide it's only $1,100. You walk away with $200 in your pocket that you were willing to part with, but that you didn't have to. That is consumer surplus. Now let's flip that script. Producer surplus is, let's say you built that iPhone for maybe $200 and several unfortunate workers in a small place in China somewhere whose tiny little fingers are now sore from soldering bits together. Don't worry, Androids are just as bad, guys. I'm not totally like hitting on iPhones. Yes, I am, but yeah, it's really technology in general. We have all this wonderful, amazing technology at human sacrifice. So just put that little guilt in your pocket and walk away with it. I'm kidding, only a little. So you are the producer. You build this phone for, say, $300 is what it costs to build it, and you want to place a price point of $800. But you discover that if you keep jacking the price up, people keep coming. So let's say you make the price $900, but people are still willing to spend $1,100 on this phone. That difference between what you want to sell it for and what they're willing to pay, that's your surplus. Because you're going to jack the price up to where they're willing to pay, right? You're going to move that line until it's no longer elastic. Until people start pushing back and say, that's enough, I can't pay any more for that. I can't give you a liver and a finger. It's just not happening. So, does that make sense? So consumer surplus is the money you're willing to spend, but you didn't have to spend all of it. What's left in your pocket is your surplus. Producer surplus is what they're willing to sell it for versus what you're willing to pay for it. If there's a positive difference there, that's producer surplus.
So
So Helena, you nailed it. Yeah.
is this problem going to help us understand how much, at what level? Is that the
This is intended to be an introduction to the concepts of consumer and producer surplus, which is fine because you guys have already worked them in most of your